So in the video, I am going to obviously go through this section, but when you're watching the video, I already have the information written down on my paper. So I would try to listen to what I'm saying. If you need to stop the video. If you need to rewind the video. You can pause it, rewind it, however you like. I would just use it to go through your notes, copy down the information, learn it. If you want to practice practice it, and then start the video. See if you did it correctly. Towards the end, I have the practice page just shown for you, the last page. So you can use that just to practice these problems. Alright, today we're going to cover Section 7, Interpreting Change, which covers absolute, or starts off with absolute and relative change. So last time we had Exam 1 over Sections 1 through 6, so this kind of starts our new unit, new material. So if you look on page 71, it tells us that in this section we're going to look at ways to describe how things are changing. So if you think back to those compare and contrast, maybe in a graph, maybe a specific example, it allows us just to do that, make comparisons. So to start with, absolute change uses the difference in two numbers. Remember, difference means subtraction. So if we have a positive number as the absolute change, it's a positive change or an increase. If it's a negative absolute change number, it's a negative change. Or it's going down, decrease. So the actual formula is in the box. Absolute change is the new value minus the old value or reference value. I usually say it's just the new minus old, but however you want to remember it. So the example they give us right underneath here, it says the U.S. population was 298 million in 2006, 323 million in 2016. So if we just look at the absolute change, the new value, 323 million, the old value, 298 million. So notice they just took 323 minus 298, which is 25. Okay. We know the new value because it's the new year minus the old year. But what does that mean? Well, you can see right here to the left I have keep the units. What does that mean? That means whenever we're working an absolute change problem, we need to keep the units that are associated with whatever the new value and old value are. For example, here, that means, since it's positive, it was an increase in the U.S. population of 25 million people. And then we have our years from 2006 to 2016. So just looking at some examples down here, find and interpret the absolute change. Juliet's weight went from 180 pounds. Notice I have circled from here. That means old, right? Because if it's from something, that's the old value or a reference. To, indicating the new, 162 pounds from May to December. So if we just take the difference, 162 minus 180, that's negative 18. Which means if we were to interpret that, Juliet's weight decreased 18 pounds from May to December. Number 2, the median income in the U.S. was $57,230 in 2015 and $59,039 in 2016. So in this case, we're looking at the year to indicate the old value and the new value. So obviously the newer year is the newer value. So that's 59,039 minus the old value, 57,230. So we take the difference in those. That's 1,809. So for number 3, it tells us that John is 6 feet 2 inches tall and Miguel is 9 feet 9 inches tall. But notice, and they tell us right here, there's no new and old. So if we're given years, it's very easy to determine, okay, new value, old value, months, the newer year and the older year. But if it's not given any sort of time period, we have to kind of investigate and be careful about, okay, what's going to be the old or reference, what's going to be the new. So the part A here says compare Miguel to John by finding and interpreting the absolute change with John as the reference, which means John's height is the old value. So since it's the old value, Miguel's is the new, so 5 feet 9 inches minus 6 feet 2 inches. And I converted both of these to inches by saying 12 inches is equal to 1 foot, so 5 times 12 is 60, plus 9 more inches, so Miguel's height is 69 inches. Similarly, John's height would be 6 times 12 is 72, plus that 2 additional inches is 74. So 69 minus 74 is negative 5. So if we're comparing Miguel's height with John's height, with John as the old value, it'd be negative 5 absolute change. Part B, find and interpret the absolute change with Miguel as a reference value. Well, this is comparing Miguel to John. To John means John's the new value. So notice this is just flipped. 74 minus 69 is 5. Do we get the same answer? Well, I mean, same number, but notice one's positive and one's negative. Okay. So we just have to be careful about when we're comparing two things, which one's the old value, which one's the new value. And it tells us right at the bottom of the page, when making comparisons outside of time, a positive number means the item in question is more than the reference item. A negative number indicates that the item in question is less than the reference item. So if we just go over to the next page, page 72, we have relative change as a new type of change. So we have absolute, and 72 starts off talking about relative change. Relative change is the ratio, which can mean fraction, of the absolute change to the reference value. A positive number is a relative increase, a negative number is a relative decrease. And relative change is a percent change. I'll go ahead and underline that, and I'll even write it here to the left of this box. But relative change is always going to be a percent. So how do you find it? Formula, relative change is the new value minus the old or reference value divided by the old or reference value. Again, if we're working with data over time, well, it's very easy to determine the new and the old. So the example they give, again, the U.S. population. U.S. population was 298 million in 2006, 323 million in 2016. So the relative change, 323 minus 298. And notice I put these in parentheses because we need to do this first. So we have to subtract first, and then we divide by the old or reference value. And when we do that, we get 0.084. And if we change that to a percent, that'd be 8.4%. Which would just mean, if we were to have an interpretation, the U.S. population increased 8.4% from 2006 to 2016. So, if we go back to Juliet, Juliet's weight went from 180 pounds to 162 pounds from May to December. The new value is the 162. So 162 minus the 180. And then we divide by the 180, which is negative 0.1. Or, changing to percent, negative 10%. So we are always dividing by that old value. Another way you can think about this is the relative change is the absolute change, because new minus old is absolute, divided by the old value or reference value. Just another way to think about it, because most of the time you'll find the absolute change first, then you'll find the relative change. So if you already have the absolute change, just take that and divide by the old value to get the relative. Example 2, median income in the U.S. was $57,230 in 2015, $59,039 in 2016. Again, we have our old value given by the year, new value given by the newer year. So we just subtract new minus old, 1809, divided by the old, 57,230. We do that, we get 0.032, which is about 3.2%. So about a 3.2% increase from 2015 to 2016. And then we go back to John and Miguel. Same heights, so nothing has changed as far as that's concerned. Compare Miguel to John by finding and interpreting the relative change with John as the old value. So 69 minus 74, which is negative 5. Then we divide by 74. That would be negative 0.068, or about negative 0.8%. Part B asks, and obviously you can just read it there, but should we expect the same outcome if we were going to use Miguel as a reference? No, and this is going to be true for relative change, because this bottom number, what we're comparing to, is going to be changing. Okay. I wrote because we are referring to his height as the whole part. We divide by Miguel's height when he is the reference, not John's. So obviously that would change our number here. So we're not going to have the same outcome with relative changes because we're comparing literally to a different value. We're dividing by a different value. Part C, use Miguel as a reference to find and interpret the relative change. This is comparison to of Miguel to John. So just flipped 74 minus 69, and again, let's get this down. We're dividing by 69 here. So 5 divided by 69, 0.072, or about 7.2%. Skipping ahead to page 74, we introduce this term called the fair market rental. So just to go through kind of the background of this, each year the U.S. Department of Housing and Urban Development compiles information on the fair market rental rates for various properties and communities all across the nation. So basically this agency is looking at the fair market rental rates for different locations, across the U.S. What is this? This is the monthly rental cost for properties in a community based on the value of the property, the average rental prices in the area, and they also have other economic factors involved as well. So, why is this important? Well, this is often used as a base value by many government programs which provides assistance to low-income families for housing costs. In other words, how do we know, I say we loosely, but how do we know that, we need to provide assistance for families, to live? How do we know they're not making enough? How do we know they can't afford rent? That type of deal. Well, this fair market rental value gives us that information. The real estate industry also uses the FMR rate as a guideline when setting monthly rental rates for properties. This table below, which again is on page 74, gives us the FMR rate for two-bedroom properties in some communities across Indiana from 2000 to 2015. So we have Fort Wayne, Kokomo, Gary, Indy, Bloomington, South Bend, Evansville, and Terre Haute on here. So right to the right, it says compare the FMR rates between years. In other words, we're going to go down below this, down here, and we're going to compare these rates just between 2000 and 2015. So we have, looking below here, I've already obviously worked it, but we have Fort Wayne, Gary, Indy, and Bloomington. So the absolute change is remember, new minus old value. So for Fort Wayne, it's 687 minus 508. For Gary, 805 minus 638. For Indy, 792 minus 552. Bloomington, 823, 639. So we just take the difference for each one of those. So before I even go on to this next part, we may ask, okay, well, which property had the highest increase? Well, if we ask which one had the highest increase, you could take that in two different ways. You could say, okay, which one had the absolute highest increase? Well, that would be Indy, because it rose 240. But we could also indicate or ask which one had the highest relative increase. That means which one increased relative to whatever it costs there the most. So we look at the percents for that. Remember, relative change is the new minus old, which is the absolute change, divided by the old. Well, notice we already have new minus old over here. So I just took those values and divided by the old. So 179 divided by 508, 0.352. 167 divided by 638, 0.262. 240 divided by 552, 0.435. 184 divided by 639, 0.288. So when we divide by all of those, we get our percents, or we can change those decimals to percents. And then if we were asked which one had the highest relative change, well, it's still the one with the highest absolute change, but that's not necessarily always true. 240 and this relative change was 43.5%. But notice which one was second. Fort Wayne. It had a 35.2% relative change, while it only had a 179 absolute change. That was less than Bloomington, but Bloomington's relative change was 28.8%. So you could ask, or if you think about increase or decrease, you can think about it in two different ways. The absolute increase or decrease, or the relative increase or decrease. And depending on what you're talking about, how you want to compare it, what's asked for, obviously, or maybe asked for one or the other, we need to just keep that in mind because they are different and they can give us different information. Below this, we have write the meaningful sentence part. Remember, the reasoning part for these. So the example they gave us, absolute change, Fort Wayne. There was a $179 increase in FMR rate in Fort Wayne from 2000 to 2015. Okay. The relative change, Fort Wayne. FMR rates increased in Fort Wayne by about 35% during the 15 years leading up to 2015. Sounds good. Again, when you're writing these meaningful sentences, you don't need to reinvent the wheel. You just want to give a meaningful, in other words, make sure we're including information that's true, sentence about what's going on. The absolute change in Indy, I just wrote there was a $240 increase in the FMR rate in Indy from 2000 to 2015. The relative change, there was a relative increase of 43.5% in FMR rates in Indy, 2000-2015. Notice I'm including that if it was a relative increase, I want to include that. Relative increase, I want to include that. Because, again, if you say increase, do you mean absolute? Do you mean relative? They can tell us and they can give us two different pieces of information. So on page 75, again, it goes back to talk about, well, if we're not between years, if we're just between two different places or two different things, it's a little bit harder to determine, okay, what's our old, what's our new. So we still use the same formulas, and here on this page, we're comparing the FMR rates between communities. So from like Terre Haute to Indy. So same formulas, new minus old for absolute, new minus old divided by old for relative. So if we look in our table right below this, we have given that our left-hand communities are going to be our reference, or old communities. The ones to the right then have to be our new. So from Terre Haute to Indy, we have 792 minus 678 is 114. How are we getting these numbers? Well, if you look back to the previous page, again, we're in 2015. Terre Haute's Indy's was 792 right here. Terre Haute's was 678 down here. So we just subtract those two. So that's where we're getting these numbers from this table. So from Indy to Terre Haute, the other direction would be 678 minus 792. From Bloomington to South Bend, 763 minus 823, negative 60. From Evansville to Kokomo, 704 minus 721, which is negative 17. Then if we do the do the relative change, new minus old, divided by old, so for the one they gave us, 114 divided by 678, 16.8%. The other direction from from Indy to Terre Haute, negative 14 divided by 792 is negative 14.4%. Again, we see the percents are different depending on what's the old, what's the new value. From Bloomington to South Bend, well, negative 60 divided by 823 is negative 7.3%. From Evansville to Kokomo, negative 17 divided by 721, negative 2.4%. So if we go on to page 76, changes in percentage points, this just talks about how do we deal with percents and percents, which can sound confusing. So far, with absolute and relative change, we've worked with things like dollars, pounds, and inches. But what about changes in percents? And when notice they say percentage points. So the way we're going to handle this is when we think about absolute and relative changes and we're dealing with percentages, we're going to call them percentage points. The reason being is we don't want to be confused with these percents and the percents from a relative change, right? Because if we're doing a relative change, it's also a percent. So if we're dealing with two different types of percents, it can be confusing. So the ones we're given, we're going to be called percentage points. That way we can leave our relative change as just a normal percent. So for example, we have, according to the U.S. Bureau of Labor Statistics, the highest average annual unemployment rate in recent history, 2009, 9.3 percentage points. By 2015, annual unemployment rate had dropped 5.3 percentage points. So if we're going to find the absolute change between these, it would be 5.3 percentage points minus 9.3 percentage points, which is negative 4 percentage points. This means a decrease of 4 percentage points. But if we were to go to the relative change, well, remember, relative change is always expressed as a percent. So it would be 5.3 minus 9.3, and then we divide by 9.3, which is about negative 0.43, or about negative 43%. That means there was a relative decrease of 43% in the unemployment rate. And notice again, we're including this word relative to indicate, hey, this is a relative change. So again, when we're working with percents in a problem, we're going to call those percentage points so we don't get confused. That's the only difference. So according to the CDC, the 2014 teen pregnancy rate was at its lowest ever at 2.42 percentage points. I'm going to go ahead and call it percentage points. In 2013, the teen pregnancy rate was 2.66 percentage points. Find and interpret the relative change in teen pregnancy from 2013 to 2014. We'll notice the old year, 2013, There's 2.66. New year, 2014, 2.42. So it'd be 2.42 minus 2.66 divided by 2.66. Notice we are doing just relative change. They didn't ask for absolute. So we're just working relative change, which means we would have these two subtracted, then divide by 2.66 is about negative 0.0902. And if I just rounded that off, about negative 9%. That means there's a relative decrease in teen pregnancy rates from 2013 to 2014 of about 9%. It's the only difference. We're calling these percentage points just so we don't get confused. So going on to page 77, we're going back to talk about the CPI and we're talking about inflation. So what is inflation? I'm sure you've all heard of the term before, but inflation is the relative change in the CPI for 1 year. To find the inflation rate for a particular month and year, we're going to look at the CPI for that month and year, and we're going to compare it to the CPI from exactly 1 year prior, to the month and year 1 year prior. If we're just given an inflation rate for just a year, we're just going to use the annual CPI to compare. And again, they're giving us the CPI data from 2011 to 2017. So we have 2011, 2012, and so on, CPI numbers. So we're going to use this CPI to think through the following questions. We're going to find the inflation rate for 2016. Well, if we're finding the inflation rate for 2016, that is our new year. Our old year will be 2015, exactly 1 year prior. So taking 2016 CPI minus 2015 CPI and dividing by 2015 CPI, we get about 0.0126 or about 1.26%. Since it's positive, that means there's about a 1.26% increase. So if they ask us how much would we expect to pay for goods in 2016, if those goods were worth $1,500 in 2015, well, notice we expect to pay about 1.26% more. So there's a couple of ways to do this. I set it up by taking 1,500 as our old value. Remember, when we use these cent proportions, we can have new over old, or the reference over base, or part over whole. But in this case, it makes more sense to say new over old. So we have 1,500 on bottom, 100 on the other side, X above 1,500, because we want to know what it's worth now. Now is 2016. Over here, I wrote 101.26. And you may be asking why I didn't write just 1.26. Well, I could have written 1.26. It's kind of hard to see. 1.26 here. Solved. And then taking that value and added it to 1,500. But instead, I used 100 plus that 1.26. So that's 101.26. And that's a little shortcut to determine, okay, instead of adding at the end, I can just use this and get my total amount. So once I use 101.26, I just cross multiply and divide, and I get $1,518.90. So how much would we expect to pay? Well, obviously 1.26% more, but how much is that? About $1,518.90. From there, I have 3, 4, and 5 as just class questions. So I would practice those on your own just to kind of get a feel for these CPI, for these inflations. And going over to page 78, we're going to actually form a link between relative change and percent problems. So if you remember back, we talked about percent problems and percent proportions. And this one we just did, number 2, probably seemed pretty familiar because we have new over old equals percent over 100. When we look at this, it tells us the sticker price of a new internet router is $24.99. Okay. The total price paid, including tax, is $26.74. And we're going to use this information with these problems 1, 2, and 3, which we're about to work. First, we're going to compare the total price paid, which includes tax, to the sticker price. So if we compare these two, we have 26.74 minus 24.99, new minus old, divided by old. 1.75 divided by that old price. And when I divide these, I got 0.070, which is 7%. So what does that mean? And you may have seen what I wrote underneath of here. But that 7%, that's a 7% increase from the sticker price to the total paid price. And that 7% represents the sales tax. Okay, it's a 7% increase. You know, we are including tax with our new price. That's what that 7% is representing, the sales tax. Number 2 says, use the value calculated above to determine the total price of an item that has a sticker price of $14.82. In other words, it has a sticker price of $14.82. We can think about this in 2 different ways. I wrote it one way here, and then we'll talk about the way we're going to use in the rest of the section. So we know we're using this 0.07, this relative change, with the relative change being new minus old divided by old. So if we fill in what we know the new price is X, right? We don't know what the tax is, or the price with tax is, but we do know the old price, $14.82. That's the sticker price. So old 14.82, old 14.82. Which I wrote right here. I bring this over by multiplying it, and then I can add 1482 to this number to get a new price of 15.86. So the new cost, including tax, would be $15.86. Well, in this section, the rest of this section, we're going to use percent proportions to actually solve this. In other words, we're not going to have to go through all these steps to get their answer, because we know that our new, which I'll just write this here, new divided by old is going to equal the percent over 100. And we can use this relationship to determine new values, old values, or maybe percents. So number 3 says, recall the sticker price and total price originally provided. What percent of the sticker price is the total price paid? Notice we're setting it up just like a proportion, like I just said. The new 26.74 over the old 24.99 equals P over 100. And if we cross multiply and divide, P is 107, or 107%. So the way we think about this is we have 100% of the original price, 100% of the sticker price, plus 7% of that sales tax. Those obviously add together to give us 107%. So if we look on page 79, we can talk about percent changes again. And basically, just what I just said, we're going to use our proportions to solve these problems. There's one important fact we want to point out before we go through some of these. And you can read it here, but earlier we learned to calculate relative change in order to make comparisons. And some of these comparisons, for example, the FMR rate in Gary is 25% more than in Muncie, where it's $635. So how do we find the rental rate in Gary? Well, we're going to use the fact that we're using, or it says 25% more. 25% more means it's 25% additional. If Gary's rate is considered to be, if Muncie's rate is considered to be 100% of itself, and it's an additional 25% of that for Gary. So 100 plus 25. And the key thing to remember about these, and I'm going to put a star by this, because people always forget, and they always make a mistake, is that when we're using these relative changes in percent problems, if it's a percent increase, we add it to 100. If it's a percent decrease, we subtract it from 100. Always. Going through this table, if it says 10% less than, we're going to take 100 minus 10, which is 90% of the original. If it's 25% decrease, 100 minus 25, 75% of the original. 30% lower than, 70% of the original. 60% less than, 100 minus 60 is 40, 40% of the original. On the flip side, if it says more than, for example, 10% more than, 100 plus 10, 110% of the original. 18% greater than, 100 plus 18, 118%, 50% increase, 150. 100% increase, that means 100 plus 100, or 200% of the original. That means actually double of the original. But what does these statements mean? What am I getting at? These problems are going to tell us it's more than, percentage more than, or less than. If it's more than, we're going to add that number to 100. If it's less than, we're going to take that number minus 100. Either way, those will be your percents. And these percents are what we'll use in our percent proportion. Remember, we're using proportions to solve these. So, for example, number 1, rental rates in Gary are 25% more than rental rates in Muncie, where they're $635. Find Gary's rental rates. Again, it says 25% more than. They even write it for us. Rental rates in Gary are 125% of rental rates in Muncie. And if you want to solve these with equations, that's fine. But since we use proportions so much in the course, I'm going to stick with proportions because it's good practice. But feel free to use these equations. G times 100, 635 times 125, then divide. We get Gary's rate, which is G here, $793.75. Notice they are using that 125%, that 125, right above 100. To the left of this, I have just a hint. It says use common sense. In other words, the answer you're finding, should it be larger or smaller than what you started with? If the rental rates in Gary are 25% more than Muncie, well, whatever number we get for Gary better be more than 635. If it's not, well, we've done something incorrect. So number 2, Lafayette's population is 15% less than Bloomington's population, which means we're going to take 100 minus 15, which is 85. That's why I have 85 right here. And then they tell us Bloomington's population, which is 82,000. So notice I wrote over here just Lafayette over Bloomington. X is Lafayette's population. 82,000 is Bloomington's. 85 over 100. Cross multiply, divide. You get 69,700. We have our note at the bottom, but amount over base is P over 100. Whatever our percent is, always goes above 100. So let's try some of these. I mean, number 3 is actually just worked out for us, set up for us, the hard part. So let's look at number 4. Indianapolis has a population of 852,866, which is 68.3% less than Chicago's population. We want to know Chicago's population. Well, Chicago's population is going to be our X. Indianapolis's 852,866. So how do we know this goes on top, this goes on bottom? Well, notice this population right here is corresponding to, which is 68.3% less. So since it's corresponding to the percent, that will go on top along with the percent. How do we find the percent? Well, it's 68.3% less. 100 minus 68.3 is 31.7. Then we cross multiply and divide, and we get 2,690,429. But whatever number goes with the percent, that goes on top. Whatever number goes with, the whole goes on bottom. So going through some of these, page 80, towards the bottom. Number 1, Jerry is currently earning $20 an hour at his job. He was just informed he will get a 15% increase. Pretty awesome for Jerry. Or for Jerry, right? Getting a raise of his current wages. So how much is he earning? Or he will be earning? 15% increase. Well, right now, he makes $20 an hour. 15% increase means it's 100 plus 15, 115 over 100. So our X goes up here. And if we cross multiply and divide, get $23. Notice if I were to flip these, which I'm not going to, but if I were to flip 20 on top and X on the bottom, I would get a number less than 20, which would not make sense. If he's getting a 15% increase, whatever number we get better be more than 20. Number 2, the number of hardwired residential phone lines is expected to decrease, aka more people are using cell phones, next year by 18% with a widespread use of cell phones. There were 1.8 million, notice this were, old value, hardwired residential phone lines this year. So how many are expected next year? Well, if it's decreasing 18%, this would be 100 minus 18, which is 82. 82 over 100, the old goes on bottom over X. And notice I just used 1.8. In new, whatever answer I get, 1.476, this was in millions. So if I wrote that as a standard number, that'd be 1,476,000. So going through some more examples from page 81. Number 3, Pete paid $350 for an iPad, and Elaine claims that was 20% more than what she paid for his Samsung tablet. So the question is, how much did Elaine pay? I guess we can't ask her. We can only use this information. So we have Pete here, $350, which is 20% more than whatever Elaine paid. 20% more means 100 plus 20. It's 120 over 100. 350 corresponded to that more amount, so it's 350 on top, X on bottom, cross multiply and divide, $291.67. Again, when I cross multiply and divide here, I'm just using a calculator. Part B, and we're going to talk about this here in a few minutes, but does subtracting 20% of 350 from 350 give the same result? Well, what is 20% of 350? And notice I wrote what it is right here, $70. So 350 minus 70 is not $291.67. That's $280. Obviously, this is incorrect. So what is going on here? Why isn't this right? Because this 20% more than value that they tell us is 20% of whatever Elaine paid, not 20% of the $350, which is what Pete paid. And this is the reason we need to set these up and be careful about these percent proportions. If it's 20% more, that's why we add that to 100. If it's 20% less, that's why we subtract it from 100. Don't make the mistake in Part B, which people always try to do. Try to take a shortcut and they miss it. These percents can correspond to the, well, usually to the old value. But if we don't have the old value, the only way we're going to be able to figure that out is if we set this up with proportion. Okay, we can't just do it all in one step, or at least not easily. So be careful with this and make sure that you're setting this up with, if it's more than, add it to 100. If it's less than, subtract it from 100. Set up your proportion, cross multiply. So we'll go through a couple more of these. Megan is currently enrolled in 16 credit hours, but wants to decrease her credits by 25% over the summer term. How many credits will she take in the summer? Well, she's decreasing this by 25%. 100 minus 25 is 75 over 100. And then her new term is the summer, so that's x over 16. Cross multiply and divide, you get 12. 16 does not correspond to this decrease of 25, right? It corresponds to what she's taking now, or the old value. Number 5, if the take-home pay is $1,443 and 22% was withheld in taxes, what was the gross pay? Well, if 22% is withheld in taxes, that means 100 minus 22 is 78 over 100 would be your right-hand side. The left-hand side, well, this 1443 corresponds to the take-home pay, the part that's withheld from taxes, or after withheld from taxes. So X is on bottom. So the gross pay, or what you would say you would make, would be $1,850. Okay, take-home pay is actually what you take home after taxes. The gross pay is what you would make before taxes. And if we go to page 83, the last big topic from this section is, are relative changes additive? And it starts off by saying, does a 20% increase followed by a 20% increase net to zero? In other words, would you start at the same spot as you ended? Does a 15% increase followed by another 15% increase equal a 30% increase? And it tells us it can be difficult to think through these scenarios in abstract, so it's going to be helpful just to throw some numbers at this and then look, what do these numbers tell us? So this first scenario tells us times are hard, right? So everyone at a small company you work for is given a 10% pay cut. However, they promise we'll increase your pay 10% when things turn around. Okay? Well, 1 says estimate the number of hours worked in a year at 40 hours per week. Well, since it just said estimate, I'm going to estimate there's about 50 weeks in a year, and 40 hours each week is about 2,000 hours. Obviously, that's not exactly correct, but it's pretty close. So, we have 2,000 hours worked. If we currently make $15 an hour, estimate your annual pay using this answer from 1. Well, $15 each hour, 2,000 hours worked, that's about $30,000 every year. Okay. So 3, how much will your reduced hourly pay be? Well, it's a 10% decrease going down. So that would mean 100 minus 10 was 90. 90 over 100, x, our new amount, over 15. So then if we cross multiply and divide, we get 13.5 or $13.50. Okay, so got our pay cut. Now we're making $13.50. However, using our new $13.50, what would our 10% increase be after times turn around, after profits increase? Well, 10% increase, 100 plus 10, 110 over 100, x over 13.5. So if we cross multiply and divide, that gives us 14.85 or $14.85. So you probably already see a problem with this, right? We started making $15 an hour. They cut our pay 10%, but they're like, oh yeah, we'll increase it. Don't worry, 10% after things turn around. They increase it 10%, but we're still making less than what we started with. How much less? Well, 1485 times about 2,000 hours is 29,700, which is about a $300 cut per year. What does this tell us? This tells us that a 10% decrease and a 10% increase don't equal out, right? They don't equal the same amount. So we can take this even further and say percent decreases and percent increases are not additive. And no, percent changes, so this is number 6, does the annual pay after a 10% increase equal what you earned? No, right? Percent changes are not additive, okay? Here we're short about $300, but, wouldn't matter. These percent changes are not additive because they are based on our starting amount. If we make $15 an hour, 10% of 15 is different than 10% of $13.50. Okay, so percent changes are not additive. So the last page in this section is just a practice page, page 87, and just applying percent change. So I'm not going to go through these. I just wanted to show you kind of what the answers would be. So I'm just going to kind of move my paper up slowly so you can check, you can practice these and check to make sure that they are correct. Obviously, you can always check out the Google Slides as well, though. So just to summarize this section, we have two types of changes, absolute and relative change. Absolute, new minus old. Relative, new minus old divided by old. This is just a way we can compare values or make comparisons on graphs. And these can be very helpful. We just have to be careful about when we phrase them to indicate, is this a relative change? Is this an absolute change? I try to use the words absolute and relative in my sentences just to leave no confusion for anybody that's reading it. Remember, absolute change keeps the units. Relative change is always expressed as a percent.